Hello friends, I just wanted to make a quick video for motion. This goes along with the guided notes that you got today in class. So if at any point I'm going too fast or if you just need to review something for yourself, feel free to pause the video or rewind to whatever part you need to review. Let's go ahead and get started. So we're talking about motion. So for some vocab words, objects that appear to stay in one place are called reference points. And you know that something is in motion if it appears to change places relative to the reference point. Okay? This is important because this can change based on your relationship to an object. So think of yourself being on a moving train or a moving vehicle. When you're on that and you look at the seat doesn't seem to be moving to you. But if you were on the platform or in the driveway outside of the vehicle, and you're looking at it going, then looking at the seat would look like it's moving. Okay? And then when we want to describe the way that things are moving, we can use reference directions such as north, south, east, or west, or things like left of, in front of, just beyond, or toward. It does not always just have to be our north, south, east, or west directions. Okay? Moving on to the next slide. All right, let's go ahead and talk about speed. So speed is how fast an object is moving. The distance is traveled in a given period of time. So this triangle here that we have might look similar to our density triangle. It has some different letters in it though. This time D is for distance, not for density. So this will be something that you need to remember as well. So we've got distance on top and then speed and time on the bottom, and then still here again is going to be division on these sides, and then here down in the middle is going to be multiplication. So then by using it, we can just cover up whatever one we're looking for. So if we're looking for speed, we've got distance over time, and then if we're looking for time, we've got distance over speed, and if we're looking for distance, then we've got speed times time. So this will be something that you need to write down and something that you need to remember. You'll be doing some practice problems later. Okay. So when talking about speed, there's a couple different kinds. First kind is instantaneous speed, which is the speed at any given moment. So it's taken all the time right after another. So if you're driving a car and you look down at your speedometer is telling you how fast you're going at each moment, right? So if you put on the gas, then you can see it go up mile per hour by mile per hour. And if you're slowing down, same thing. So it gives you your number in each moment. And that is different from our average speed, which is our total distance over the total time. So it's not talking about just one specific moment, it's just a summary of the entire trip that you took. So for example, if I travel 580 miles, which I did recently when I went to Minneapolis, Minnesota, and it took me 13 hours to do it, I can calculate that my average speed was 45 miles per hour, which is pretty slow. Okay? So I also want to remind you that we are going to be using SI units, not miles per hour, not our American units. So distance is going to be measured in meters. Time is going to be measured in seconds, which can be represented by an S. So then speed, we have meters per second, or M/S. Let's go ahead and go through an example. So we have a triathlon that looks like swimming, biking, and running. And we've got two people that are competing, person A and person B. And so we want to find their average speed for each part, and then we're going to answer these questions right here. So starting out with leg one and triathlete A. So the total distance was 3 kilometers, and the total time was 0.8 hours. So I'd like you to remember that average speed equals distance divided by time. So our distance is 3 kilometers, and our total time is 0.8 hours. So we're going to set it up like this. So if you do 3 divided by 0.8, your average speed is going to be 3.75 kilometers per hour. So notice how I got these units. I have kilometers in the top, division bar, then hours. That's why I know it's kilometers per hours. Okay? Let's go ahead and do it for triathlete B. So same distance, 3 kilometers, but they did it a little bit slower. It took them 1 hour. So then if we do that, their average speed for leg 1 was 3 kilometers per hour. So a little bit slower than triathlete 1. Okay, go ahead and move on to leg 2 when they're biking. So this time they're going 50 kilometers, and triathlete A did it in 3 hours. So if we calculate out the average speed, we get 16.7 kilometers per hour. Doing it again for triathlete B, same distance, 50 kilometers, this time divided by 2.5 hours, we get 20 kilometers per hour. So this time they were a little bit faster than triathlete A. Now moving down here to leg 3, running. This time they're going 12 kilometers, and triathlete A did it in 1.2 hours. So they were going an average of 10 kilometers per hour. And then triathlete B did it in 1 hour. So they were going an average of 12 kilometers per hour. Now let's go ahead and find the averages overall of the entire competition. So first we want to find the total distance that these athletes went. So from leg 1, 3 kilometers plus 50 kilometers from leg 2 plus 12 kilometers from leg 3 gives us a total of 65 kilometers that these athletes went. And then now let's focus on triathlete A. So let's find the total time. So from leg 1 took them 0.8 hours. Part B, or leg 2, I mean, was 3 hours, and then leg 3 was 1.2 hours. So their total was 5 hours they were competing. So then now we want to find the average speed. So remember, we do distance divided by time. So our average speed is 13 kilometers per hour. Let's go ahead and do the same for triathlete B. So we want to find out their total time first. So we've got 1 hour plus 2.5 hours plus 1 hour. So they did the entire thing in 4.5 hours. So then their average speed is going to be 14.4 kilometers per hour. And now we can tell that on average, triathlete B was going faster than triathlete A. All right, let's continue on. So this is on the back page of your guided notes. So I've got a riddle for you. We have 2 birds that leave the same tree at the same time. They both fly at 10 kilometers per hour for 5 minutes. Why don't they end up at the same place? So go ahead and pause the video if you need a little bit of time to think. All right, so the answer is because they were flying in different directions. And this is leading us into our next topic of velocity. So velocity is not the same thing as speed. Okay, so velocity is the speed of an object in a particular direction. So you have to include your reference to a direction. So 5 meters per second is a speed. 5 meters per second to the right is a velocity. Again, notice I can say to the right, or I can say toward the cafeteria. I don't have to say north, south, east, or west. It just has to be some sort of reference to some sort of direction. Okay? So then this means that velocity can change if the direction changes or if the speed changes. So if I'm going 5 meters per second to the right, but then I all of a sudden start going left, that's going to change my velocity. So again, velocity and speed are not the same. Okay, this brings us into scalar versus vector quantities. So a scalar quantity, which is something like speed, is a magnitude. So it's a measurement amount only. So most of the things we've talked about so far, mass, length, and volume and speed, are scalar. This is different from vector quantities that have a magnitude and a direction. So velocity, say going 5 meters per second toward the door, or force that we're going to start talking about soon, 5 newtons of force up. You have to talk about the direction. That's what makes it a vector. And those will be represented by arrows later. Okay. So an overall summary of what I talked about in this video. We started out by talking about reference points. Then we talked about speed, and there's two different kinds, instantaneous and average. Then we went into talking about this lovely triangle that talks about distance, time, and speed, and how to use it for the different equations. And then we talked about velocity and how that is different from speed. And that led us into our final topic of scalar versus vector quantities and how they're different. So if you don't understand something that's on the slide, just go ahead and rewind the video and rewatch whatever part you need to. You also can come see me in class at any point to ask any questions. Thank you for watching. I hope this helped.